Hello everyone. In today's session, we will discuss about MedSart. Okay, so MedSart mainly works on divide and merge. Okay, so it works on the principle of okay, divide and merge. First, we have to divide the array by half. Okay, and finally we have to merge the divided elements. Okay, merge, divide and merge. So let's consider this example. Okay. So if you take this is a low pointer, okay, and this is a high pointer h, okay. So what is the mid here? How we can find out mid? Mid equals to low plus h by 2. Okay, that is low is 0, okay, and high is here length is 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 by 2, right? That is 4.5. So since we have a odd length, so we can go either 1, 2, 3, 4. Either this we can divide till here. Means we can take this is a first part till here, and we can take this one is the second part. Or we can also take till 8 is the first part, and from 1 to 3 is a second part. Since we have a odd length. If we have a even length, we know the equal parts will come left side and right side. Okay. So in my example, just I'm taking, just I'm considering low to till here, the till 4 I'm taking considering as a first part. That is a first half. The remaining is a second half. Okay, that is divided. So again, just keep dividing the two arrays again. So let's take a left array. So if you take the left array again by 2, right? It's what is the array here? 9, 4, 6, 2. Correct. So 9, 4, 6, 2. How we can divide? By 4 by 2, right? 2. So 9, 9, 4 should come here. 9 and 4. Correct. And 6, 2 will come here. 6 and 2. Correct. Again, if you divide, okay, 9, only one element, right? 9 should do here. 4 should come here. Only one. Okay, stop it. Whenever we have only one element, stop it. Now, in the same way, the right side, 6 should come here. 2 should come here. Okay, this is the first step. We have to keep dividing it till we have a single element. Once we divide it with half, the next step is we have to merge the arrays. Okay, we have to consider this is one array, this is one array, though we have only single element. Okay, so if we have to merge these two arrays in a sorted manner. Okay, assume if you want to merge these two arrays in sorted manner, so which element we have to write first? First 4, right? Then 9. 4 comma 9. Correct. Then once the left side is over, then come to right side. Correct. Again, let's consider 6 and 2. So 6 and 2, if you want to merge these two arrays, right? How we can write? We have to write first 2, then 6. Correct. Now we have again these two, these two, 9, 4, 6, 2 are done. Now if we take again, we have two sub arrays, two arrays, right? One is the left array and right array. How we can merge these two arrays? Let me explain the logic here. So if you want to merge these two arrays, what are the elements we have? 4, 9, 2, 6. Okay, and this is a left array, this is a right array. Correct. So we have to take two pointers. Say this is a left pointer and this is a right pointer. We have to place left pointer in the starting index of the first array, the right pointer in starting index of the right array. Correct. And we have to create one temporary array. Let's create one temporary array, and we have to keep comparing the first element in left array, the first element in right array, which is small. Okay, this one is small, right? Just place here. We have to place in a sorted manner. Correct. 2 and increment the right value here. Right should come here. Correct. Again compare 4 and 6, which is small, 4, keep here. Okay, move left. Yeah, I'm just L is left. Okay, now compare 9 and 6. Okay, 6, increment R. Okay, whenever it reaches to end of this array, right, what is the remaining elements are there in the first array. 9 is there. Let's place here. So 2 4 6 9, this is the algorithm we have to follow to merge two individual arrays, okay, in sorted manner. Okay, 2 4 6 9, it's sorted. Okay, so we have to write here. Once we sorted this, it will come 2 4 6 9. Okay, so the left side array is done. Same way we have to do for right side array. Okay, so just let me erase it. Let me again follow the same approach for right side array. Okay, keep divide the right side array till we have a single element. Again, keep merging the elements in a sorted manner. Okay, so if we take a right side, right, so we have 1 2 3 4 5, correct? So let's write these elements: 8 1 5 7 3. Okay, so this is the right side array, right? So this is the right side array. So if you want to divide this further, how we can divide? Since we have odd length 5, either we can take first 2 is one array, next 3 as one more array, or first 3 as one array, next 2 as one more array. This time taking first 2 as one array, that is 8 and 1. Again further if we divide, so we'll get 8 is one element, 1 is one element, correct? And here the right side is 5 7 3. Okay, again further if we divide, so this is 3 by 2, right? That is 1. So first 5 is one array, right? And 7 3 is one more array, 7 and 3, correct? Again if further if we divide, 7 should come here, 3, stop it. Okay, now keep merge these arrays as well. Okay, 8 1, since we have only one element, if you want to merge, ideally how we need to write? 1 we have to write first, 8 we have to write second, correct? So this is, we merged it. Okay, same way let's merge the right side arrays. So we have 7 and 3, right? So ideally we have to write 3 and 7, correct? And here now we have 5 3 7 is there. Okay, so if we follow the same approach earlier, so how if we compare, okay, so ideally we have to write 3 first, then 5, then 7, correct? Now again we have two arrays, right? That is 1 8 3 5 7, and 1 8 is one array, 3 5 7 is one more array. If you want to merge, first element is, which one will come? 1 will come, next 3 will come, correct? Then 5 will come, next 7, next 8, correct? Now again we have to merge 2 4 6 9 1 3 5 7 8, correct? So how we can do that? The same algorithm we have to follow earlier, whatever we have written, right? The same algorithm we have to write now. So I don't have space, let's write here. So what is the first array? We have 2 4 6 9 is the first array. Okay, what is the second array? 1 3 5 7 8, 1 3 5 7 8. Okay, so this is a two arrays we have to merge them in a sorted manner, right? So let's apply our algorithm. Okay, as I told you, we will take a 2 pointers, that is a, here left we have to take, here let's take right. Okay, first compare array of left, okay, is less than array of right. Okay, we have to take one temporary array, right? So we have to take here, assume that we have a temporary array here, correct? So this is a temporary array or list something. So between 2 and 1, which is less smaller one, keep smaller one here. Increment r. Okay, r is pointing here. Now 2 and 3, which is smaller, 2. Place to here. Okay, whenever we place, we have to increment that value. Okay, left will increment it. Okay, now between 4 and 3, which one is smaller? 3 is smaller. Okay, increment r. Between 4 and 5, which one is smaller? 4 is smaller. Increment L. Between 6 and 5, which one is smaller? 5 is smaller. Increment R. Now between 6 and 7, which one is smaller? 6 is smaller. Increment L. Between 9 and 8, which one is smaller? 8 is, sorry, between 9 and 7, which one is smaller? 7 is smaller. Okay. Increment R. Between 8 and 9, which one is smaller? 8 is smaller. Done. Once this is over, the remaining elements are at left side, right? We have to place that 9 also here. Okay. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9. So that is our final output. We have to write it. Okay. That is 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So this is the algorithm we have to follow. So if you want to write the code, right? How? So what is the the idea behind it is, so we have to recursively call the divide the arrays, right? So see, this is low. Okay, a low is like a 0th index. Okay, so we have to call 0 to mid. Okay, 0 to, see, assume that this is a mid. 0 to mid. Okay, this is mid plus 1. Mid plus 1 to high. Okay, so we have to call one recursive function from low to mid. The second recursive function, mid plus 1 to high. This is recursively we call it. So two functions we need to call separately, and this is for dividing, correct? Once we completed these two, we have to call one more function, that is merge two arrays, right? This to implement this logic. Got it? And once we got this the temporary array, right? Again, we can copy all these elements into our original array, and we will display the original elements. Okay, let's write the code so that we can also discuss time and space complexity. Okay, so let's take this array. So let's write a user defined function metsort of array to 0 as main low, right? And high is array dot length minus 1. Okay, so after sorting, let's print the elements. After sorting, so arrays dot toString of array. Done. So let's create a method. Eclipse will generate for us. Okay. Here, the base condition is, if when we have to return, if there is only one element, right? We have to, we stop dividing, right? If there is only single element, we just we divide it, right? So if it comes to single element here, if you want to point low and high, it should be same here, right? Low also here, high also here, correct? Which means whenever low is greater than or equals to high, you have to return it, correct? So that is the base condition. If so, before that, let me rename this variable cell low and high. Okay, if low is greater than or equals to high, return. That's the base condition. Now keep calling recursion. This is a recursion, right? Low to, the first one is low to mid, correct? So we have to find out mid before that. Int mid equals to, how I can find out mid? Low plus mid by 2, correct? So this is a sorry, low plus high by 2. Got it? So this is the first half. So if we consider here, this is this one, low to this portion, right? Okay, low to mid, the first half. Okay, second part is from mid to plus 1 to high. This is the second part. We need to write one more recursive function. Okay, so in this sort of array, from where to where, mid to plus 1 to high. Got it? So once it is done, I have to write one more function to implement the merging algorithm. Correct? So from where I'm, what and all I'm merging, from low to mid, correct? And mid to plus 1 to high. I have to merge, right? So that's all. These are the functions. And now I have to write one more function, merge. Okay, let's create it. Yeah. So here, let's create one temporary array list or array. So list integer. Okay, temporary list equals to new array list. Okay. Now let's take left equals to low. Okay, and int right equals to high. Fine. Now implement the logic. While till we have to keep merging two, right? So if we take here, assume this is a low, right? This is a, assume that left to till here mid, and assume that this is a right, for example, right to this is a high, correct? So here right equals to, we have to write mid plus 1, sorry, not high, we have to write mid plus 1, right? So if you see, this is the right, right? Left is low, correct? And here mid is there. After mid plus 1, I have to assign a right value. From till high, I have to iterate, correct? So let's keep the condition. While left less than or equals to mid, and right less than or equals to high. Okay, this is a loop, while loop. Okay, now check the condition. If, okay, so array of left, okay, is less than or equals to array of right. Okay, if you have duplicate elements also, it will take care. Since I'm using a left less than or equals to else. Okay, so this condition means, which means if array of left, this element is less than this element, which element do you have to keep in a temporary list? This element, right? Else we have to keep the right side part, right side element, right? That is a condition, correct? So I have to add where in temporary list. Okay, so a temp list dot add of, okay, so add array of left. Once add, I have to increment left value, correct? Left index. Else temp list dot add of array of right, okay, and increment right plus plus. So, and one more condition is, if any one of the array is completed, okay, suppose if this array is completed first, we have to copy the remaining part of the second array, correct? Suppose if right side array is completed, we have to copy in temporary list remaining elements of the left side array, correct? That's the two conditions we have to write. So while this for left array, left less than or equals to mid, if, okay, if any elements are there in left array, just copy paste this code. This is for left array. Okay, same way just write while for right array, right less than or equals to high. Okay, write it same copy paste for right if any elements are pending in right. Done. So our temporary list is ready. Now traverse the temporary list and copy into original array. Okay, for from low to high, right? So I equals to low, I less than or equals to high, I plus plus. Okay, my array is array of I equals to, so temporary list dot get of, okay, I minus low. Just copy one by one all elements. That's all. Okay, run the program. You can see, right, 1 2 3 4 5 6 7 8 9. Okay, so this is the code. So what we have done, so I have written a Medzsart user defined function. So I am passing complete array, 0 as my low value, the length minus 1 as my high value, and this is the base condition. I am finding a mid and calling two recursion functions, Medzsart from low to mid and mid plus 1 to high. And once dividing is completed, then I'm calling one more function merge. This is to merge the two arrays in sorted manner. So I just declare two variables, left and right, with low and the mid plus 1 for right. This is the loop, while loop. Okay, if a left side element is lesser than right side element, add the left side element, otherwise add the right side elements. If any one of the array is completed, copy the remaining element. This is for left array, this is for right array, and this is just for copying the temporary list to the original array. That's all. Okay, so what is the time and space complexity? So the time complexity is we keep on dividing into half of, right? That is log n, and we have the complete n size, right? Again, that is, so that is the time complexity is n log n. And since we are using extra data structure to store the elements, and space complexity is order of n. So order of n log n is the time complexity, order of n is the space complexity. Okay, thanks for watching this video.